Thank you very much. Good afternoon, everyone. This is Bob Jacobs from the Office of Communications. If you have a pen or pencil nearby, I'll be going over some numbers, telephone numbers in a bit, so I want you to be prepared for that. Thank you for joining us for today's discussion of the update of the first integrated mission of the Space Launch System and Orion. Both SLS and Orion will launch together from the agency's Kennedy Space Center in Florida. The mission, which of course is known as Exploration Mission 1 or EM1, will be the first in a sustained series of deep exploration missions in the vicinity of the Moon. Our missions are going to take humans farther into the solar system than we've ever traveled before, and will support our plan to send crews to the vicinity of Mars. SLS and Orion, coupled with record levels of private investment in space, will help NASA and America continue to unlock the mysteries of space and to ensure this nation's world leadership in exploring the cosmos. So joining us to discuss the status of EM1 are Robert Lightfoot, NASA's acting administrator, and Bill Gerstenmaier, the Associate Administrator of NASA's Human Explorations and Operations Mission Directorate. Each speaker is going to provide brief remarks, and then we'll open the lines for questions. As the operator mentioned at the top, your phones are now on mute. To enter the question queue, please press *1 on your phone, and the operator will call on you and open your mic. Please, if you can, stick to a question and a follow-up. And please identify to whom your question is directed. We have a short amount of time. We're going to try to hold this to about a half hour to schedules, and we want to get as many questions in as possible. And one final reminder, and why you needed the pens and pencils and notes, about 1 hour after we conclude, we'll have a replay of this telecon available. It's available toll-free at 800-284-5340. And the passcode is 2017, 2017. That number again, 800-284-5340. And as mentioned just a moment ago, we'll hear first from Mr. Lightfoot. Robert?
All right, thanks, Bob, and thanks for everyone for joining today. We want to update you on two topics today, the results of the feasibility study for putting crew on EM1, and then the schedule for EM1 and where we are today. So I'm going to start with the crew on EM1. As most of you know, working with the White House, we put the team in place to do a feasibility study about could we look at this as a stretch opportunity to put crew on EM1 as opposed to the current plan, which is having it uncrewed. I want to thank the White House for giving us the opportunity to look at this. It was really a very good study. The teams did a great job pulling things together pretty quickly because of where we are in the flow, getting ready for our baseline plan, which is EM1. Also, the White House has been incredibly supportive of, frankly, of our baseline plan for what we're trying to do going forward in the next decade with the exploration missions that we want to go forward in the future. The government industry team, they did a ton of work and did it in a very timely manner to take a look at this and really answered the mail for me and Bill when we saw all the data they brought back. As for the study, we asked them to review the program for the feasibility side of this and really let us know what would be different than our baseline plan of uncrewed EM1. We asked them to kind of ensure they were also really, as you looked at this, let's make sure we're protecting the longer-term exploration plan for a series of missions going forward in the 2020s as we're building our deep space infrastructure and pushing humans further into space, and not let the EM1 with crew actually disrupt that flow as well, because we're in this for the long haul, and we want to make sure we're still focusing on that. So when we did the study, it really kind of broke down into two main areas. The first was the teams had to review the decisions we'd already made based on the fact that EM1 is uncrewed today, and look back at decisions that we had already made because of that, because it was uncrewed. And so they would have to talk about the risk associated with that and the potential mitigations if we did put crew on EM1. The example of that would be some of the stuff around the heat shield and some of the stuff around ascent abort testing that the data we were going to get from this first mission. The second kind of bucket of things that we dealt with was, what efforts that we had planned for EM2 would have to be accelerated and able to put crew on EM1. Clearly, examples of our life support systems, the software we need to get for the crew displays and just get the whole crew displays in general. So those were the kind of areas, just a real top level list of areas they came forward with when we asked them. in both those cases, we said, look, give us the additional technical risk, additional resources, additional schedule that you would need going forward. How would we assess those? At the end of the day, we found it technically feasible to fly crew on EM1, as long as we had a commitment of additional resources and schedule, and recognizing that the technical risks that we identified still were going to need mitigation plans as we move forward. We thought we had some in place, but we'd have to address them over the next several months as we get ready. We then kind of came together as an administration with the folks at the White House and worked hard to kind of assess all the risk and resources, schedule, and technical areas, and decided that while it was technical feasible, they really reaffirmed that the baseline plan we had in place was the best way for us to go. Leave EM1 uncrewed, and just it gets us back to flight sooner as a team. It's really consistent with our available resources, and while it still has technical risk, because it's not without risk itself, obviously, we have a good handle on that and how an uncrewed mission will actually help EM2 be a safer mission when we put crew on there. So we're going to continue with our baseline plan, a plan we've been working for a while, and firmly believe that will make the right steps for us to push humans deeper into space. And again, I want to thank our team for their efforts in looking at the feasibility. I wish you could have seen the enthusiasm and the excitement around the discussions, but also what they identified. They identified a lot of areas that we will actually take forward into EM1 that we think will just make EM1 a much more robust risk reduction flight for going toward EM2 as we move forward. So that's the crew on EM1. As far as the EM1 schedule goes, while we were doing all this, we've been looking at the EM1 schedule for a while as a team. As you know, we've had several things we've been dealing with: the in-service module deliveries, the tornado damage down at Michoud Assembly Facility. Recently, the weld challenges we've been having on the liquid oxygen tank portion of the Space Launch System core stage. And so the team was already doing that. When we did the crew study, it put a light on, shined a little brighter light on what we needed to do as we look forward. So what we did overall is we now know we're going to have to move that date into 2019, the launch date into 2019. It's still TBD exactly when that'll be. The team comes to me at the Agency Program Management Council. I chair that from an agency perspective, and it's part of our process. We have a commitment date out there that we've got to go back, and now they'll come back with a formal date as they work through the issues that they're dealing with going forward. So it'll be a formal review. We'll get a new date, and we'll move on from there. So that's where we are on the EM1 schedule, and the crew on EM1 at a very high level. Again, I just can't help but thank the teams enough for the effort that they put in place, and really truly reaffirming the plan that we got. It's an exciting plan for us as we start heading toward the decade of the 2020s to get us pushing humans further into space, and we look forward to doing that. And then at this point, I'll just turn it over to Bill, see if he has any open comments. Bill?
I think Robert covered all the items very, very well. There's a few things I would just say again. I'd like to reiterate, like Robert did several times, the team that did this study just did a fantastic job of really looking at all the technical considerations that go into this, the ability to put crew on EM1, and it really made us go look at our baseline plans in a very, very detailed manner that we typically do, but we typically don't get a chance to step back in the middle of production and development and take a good hard look at a program. So this was really good for them to go back, take a look at activities, see where we saw some weaknesses in our plans that were built several years ago, and say, hey, we could do some things to do a little bit better. So again, I want to congratulate the team like Robert did that did this study. They just did a phenomenal job. I also want to stress, as we talk about EM1 moving schedule-wise into 2019, the amount of work that has actually been done on the vehicle. You can see the physical tanks that are already manufactured down at Michoud that are there. We have the 2 hydrogen tanks that are complete. We almost have the structural test article of the inner tank complete. The engine section is on a barge. It should arrive at Marshall on Monday. The interim cryopropulsion stage is down in Florida, undergoing testing down there at the ULA facility. So we've done we're going to have a solid rocket motor abort system test out in Utah in a couple months. We've got the shuttle main engine, the RS-25 testing for the core stage down at Stennis on May 16th. So if you look at all the development work that's going on over the teams or by the teams in the preparation for EM1, it is just phenomenal. So the fact that we're running into some production problems, I think that's typical of almost any major development of this complexity. And some of the problems we see, we've got to understand, we've got to get them behind us. The tornado was very unfortunate to us, and that really set us back in a big way, and we'll recover from that and move forward. So again, we'll talk about the schedule, and we'll talk about that and how we move forward. We'll go to Robert, present to him a new plan, a new baseline plan with all the details sitting behind it, and we'll see where things sit. We also the other thing I didn't mention was in the case of Orion, the service module is being manufactured over in Europe, and that's going pretty well. It's also a little behind schedule for the original November 18 date, so that would have moved us somewhere into 2019 as well. So we'll factor all that in. We'll come back to Robert here in a couple of weeks and then baseline a new schedule and get ready to keep moving forward. So with that, I think we look forward to your questions through this teleconference.
Okay, we are ready for the question and answer portion of today's teleconference. If you'd like to ask a question, please press star 1 on your phone. The operator will announce you, open and close your mic for you, and ask you for your question. And as mentioned earlier, if you could stick to a question and a follow-up, and be sure to identify to whom your question is directed. And obviously, if we have time at the end of this, we'll head back for some pickup questions or another round. So, operator, we are ready for the first question.
Thank you. Our first question comes from Joel Achenbach with the Washington Post. Your line is open.
Great. Thanks so much for having this. First, can you, Keith on NASA Watch mentioned the incident in Michoud with the dropped hardware. Can you tell us what happened there? And second, President Trump made that comment recently about going to Mars in his first term or his second term at worst. I couldn't tell if he was joking, if that was just off the cuff. Could you give us any information about whether there's been serious discussions of that with the White House and how we should interpret the president's remarks? Thanks so much.
Yeah, I can talk a little bit about the tank. We were processing the oxygen tank, the qualification oxygen tank, getting it ready for flight, and we had welded already the sections of the tank, and we're ready to move into position the dome that sits on the bottom of the tank. That's the round spherical piece that fits underneath it. As we were getting ready to move it in underneath the tank to remove some protective covers on that dome, the technician lowered the dome down, and when they did that, it essentially ran the dome into 8 fixtures that hold the dome in the device, caused significant damage to the dome. It's probably not repairable. We have another dome available, a flight unit, and another one also available, so we'll roll that into the sequence and we'll go back and take a look at it. This was a significant event for us. We call it a Class B mishap. Boeing's formed a team to go look at it. NASA's formed a team to go look at the event. We'll learn from this event and we'll move forward. I don't think that overall impacts much on the schedule. It put a little delay because we essentially have stopped work for several days on the facility until the investigation teams have completed their work. They've now completed their work. We're back in, ready to go do production again. We'll figure out the way to move forward. It's an unfortunate event. Again, I think we'll let the mishap board complete their report, and we'll take a look at the report, see what we can learn from it, and we'll be healthier from the overall standpoint. But that's what occurred in the case of the dome section.
And for the other, we continue to have a good dialogue with the White House. The administration has been very supportive of our plan. If you look at the Transition Authorization Act from the Hill and then look at the skinny budget, we continue on the plan we're on, and I think very, very, very good dialogue and very good support from the White House from that standpoint.
But have they asked you to look at going to Mars by 2024?
They've asked us to look at the plan that we've got today and see if we can keep going on that plan. So they have not asked us to go to Mars by 2024.
Thank you.
Operator, we're ready for the next one.
Next question comes from Keith Cowing with NASAWatch.com.
Hi, for Bill Gerstenmaier. Just want to get some thoughts on your exact decision process here. You said that you had schedule and whatnot to be able to do crew on EM1, but this sort of reminds me of something you and I worked on, Space Station Freedom, where we would have a redesign, and just as we were incorporating the changes, we'd get another one. Were you encountering something where you were attempting to just sort of not want to bring any more risk mitigation on top of risk mitigation that you were already involved with, because that tends to breed things, or did you just think that you probably would end up with too much on your plate?
Again, I think that's a pretty good question. You know, we really looked at this first of all, was it feasible from an overall standpoint? And we told the administration when they asked us first to consider this, we needed additional funding and we needed additional time. We knew both of those had to be there because we had certain components like Robert described to you in his opening remarks that just were not there. We didn't have crew displays. We didn't have an active abort system. We didn't have an active life support system. So we knew those had to get added in. They can be added in technically. I think we were surprised a little bit. We thought we might have to put in a partial environmental control system or life support system for the crew that would not have been extensible to EM2. But what this team was able to do is they figured out a way that we could actually install a life support system of the final design. So there was no wasted work by putting the real system in place. So that was a very positive thing we learned. We also learned that we had to human rate the interim cryopropulsion stage. And it turns out on CST-100, Boeing's commercial crew vehicle, they have the dual-engine Centaur vehicle that has an emergency detection system, an avionics box that detects problems in that upper stage. That same box is applicable to the interim cryopropulsion stage used on EM1, so that would allow us to effectively have an abort capability for the crew if something went wrong on the ICPS. So what I was surprised by was I thought that there would be a whole lot of really negative work that would actually maybe make this not very attractive to us, because as Robert described, we're not just doing one flight. We're really building a system that can move humans into space in a sustained way over a series of flights. So we didn't want to do just kind of a one flight thing, but what we learned from the study was we could actually add in the right components. But I think when Robert and I look at this overall, it does add some more risk to us because of the first crew on the vehicle. That's mitigated by Exploration Flight Test 1, which we flew without a crew. That gave us a lot of good data on Orion systems and recovery in the ocean. We also had very mature propulsion systems, shuttle main engines, and the solid rocket boosters on the side. So the risk was reasonable, but it was additional risk. We saw some additional schedule concerns that would be there because we had to add some new systems that were not developed. We had to put new software in for the crew displays. That took a lot of ramp up in crew software development. We had to add the life support system in that wasn't really designed. We'd have to essentially take apart some of the vehicle that's been assembled in Florida and put the new stuff in. So that was additional schedule risk. And so we see those things as just little pieces, and then it's going to cost more, and we have the budget that we have to be considerate of and make sure we spend the minimum amount for this stuff moving forward. So we looked at those, and really the combination of changes in all three of those areas said, hey, overall, probably the best plan we have is actually the plan we're on right now. It gives us the most robustness. It lets us really test this vehicle in a very dynamic way on EM1, and then it allows us to roll into EM2 with crew. And we'll look at ways from this study where we might be able to advance EM2 a little bit in the sequence and try to fly crew earlier. So I think when we looked at it, I was first surprised that it wasn't a one-off kind of thing, that it actually fit pretty well. But then I think when we looked at the overall integrated activity, even though it was feasible, it just didn't seem warranted in this environment.
Operator, ready for the next one?
Next question comes from Jeff Faust with Space News.
Hi, good afternoon. You mentioned you were coordinating closely with the White House on this. Was this decision ultimately to stay with the baseline a decision made by NASA and presented to the White House, or made by the White House after NASA presenting options to the White House about which option to choose?
Yeah, Jeff, this is Robert. I would say we made it together. I mean, we definitely sat with them after we heard the feasibility study and came to this conclusion together. So I don't think there was any. We didn't throw it over the fence. We had, and they didn't throw it back. We pretty much made it together.
And then in terms of when you would make the decision on the new schedule for EM1, when might you see a time frame, and do you have an idea if it would be early 2019, late 2019 for that rescheduled EM1?
I think we'll probably look like in the next couple of weeks we'll present to Robert. We've got a little bit more work to do. We got to do a little more work down in Michoud to get the report back from the staff investigation board. Pull some of those activities together. We'll present the schedule to Robert. So we're probably a month or two away from coming up with a final schedule for the 2019 actual launch day.
Okay, operator, we're ready for the next question.
Next question comes from Irene Klaus with Reuters.
Thanks very much. I think this question is probably for Bill. Could you tell me, first of all, if you're expecting a similar slide in the EM2 mission as a result of delaying EM1, or what you said a little while ago about, as a result of this study, looking at ways that you could move up EM2? Is that kind of the more likely scenario? And also was wondering if you have just a ballpark price of what it would have cost to add the crew to the EM1 mission.
So in terms of where we are with EM2, we've been carrying tentatively in August 2021 kind of date for EM2. It will probably move somewhere to the right because of the relationship between EM1 and EM2. And what that relationship is driven by is we fly the exploration upper stage, which is a new upper stage. The rocket gets about 40 feet longer on EM2 than it is on EM1. That requires us to modify the mobile launch platform down at the Kennedy Space Center. That takes us somewhere on the order of about 33 months to make those modifications. So that will move wherever EM1 sits. That will move EM2 a little bit to the right. We'll look at some options now of maybe doing some things on the mobile launcher in a more effective way. We might even look at a different mobile launch platform. We'll look at some other things. There's other considerations on Orion equipment that flies on EM1 that gets turned around to fly on EM2. We have to watch that. So we'll first do the EM1 schedule with Robert. Then after we do that, we'll look at things we can do with EM2, and we'll come out with a new EM2 date probably several months after we do the EM1 activity. In terms of overall cost of this activity, I would say the range was somewhere between $600 million and roughly $900 million. And that depends whether we would add a new heat shield subscale demonstration test prior to the crew flight of EM1.
Thank you.
Okay, operator, we're ready for the next question.
Next question comes from Eric Berger with ARS Technica.
Hi, Gersten. Robert, thanks for doing this. I guess a 50,000-foot question here. The SLS, or the SLS was sort of created with the Authorization Act back in 2010, and at the time, Congress asked about, flying it in 2016. Now we're looking at 2019. I'm hearing maybe late 2019. Big picture, what has caused kind of this 2.5 to 3 year delay in terms of the development of this program?
Yeah, I mean, I don't know. I would just say it's really the complexity of what we're trying to go do and to build these systems. We picked systems like the modern manufacturing down at Michoud to really lower our production ops costs. So we weren't pushing, I would say, state-of-the-art technology like we typically are. We weren't pushing new main engines sitting underneath the rocket. We weren't pushing new solid rocket boosters. We were pushing a lot of brand new manufacturing. And I think that new manufacturing has caused some of the delays we've seen. No one welds material in the way that we're welding material at the thicknesses we're welding for this tank. So we're actually paving the way from a technology development, a manufacturing development process. So that's caused some of the delays. I think the other thing was if we look back historically, the expiration or the European service module that we kicked off with the Europeans, we had a lot of kind of startup transient with them, getting that online and getting that in place and getting the contracts in place over in Europe to deliver that hardware. Again, I think if you look at the amount of work we've accomplished, it's pretty phenomenal overall, and that's caused some of the delays.
All right, operator, ready for the next one?
Next question comes from Kenneth Chang with New York Times.
Hi, thanks for taking my question. You mentioned the cost of doing crew on EM1. What would have been the effect on the schedule? And also, you mentioned some weaknesses identified and things that would flow into EM1 from the study. Could you give me examples?
Yeah, I think again, this Robert. I think that on the schedule part, we were looking at The earliest would be a very late 2019 date, but really realistically, Bill and I felt it was more like probably the first or second quarter of 20 that we could have gotten there with crew. And some of the things that we looked at pulling forward was an ascent abort test. We were planning the way the sequencing was today is EM1, an ascent abort test, and then EM2. We think we can pull that particular. We think we can pull that test forward in what we're trying to do. And then the other piece was the work we're doing on the heat shield. There were some things that we want to go do from a ground test perspective that we think we can give us a little more confidence in the heat shield. We're plenty confident in it. I don't want to imply that, but there were definitely some risk reduction activities we felt we could go do on the heat shield between now and EM1, whether it was crewed or uncrewed, when we saw the study. Anything else, Bill, you think of?
I think we also, some of the crew software that the crew's going to need for crew software displays, we think we can start some of that a little bit earlier than we had planned before. Again, I think also we ought to be really careful when we talk about the schedule thing we just did. I'm not sure we got a clear, crisp decision to start in 2010. We can go back and look at the record there and see when we really got the authority, but I think we got to be very careful when we pick that start date and when we really started through the CDR process and the contract awards and other pieces. But again, that's not an excuse. That's just where we were.
There's also dollars in the Auth Act for 2010. I don't think were ever appropriated at those levels as well. And the agency process didn't really kick in until 14, I think, where we actually put a commit date of 2018. So anyway, not an excuse.
Ken, do you have a follow-up? Okay, next question, please, operator.
Our next question comes from Gina Panseri with ABC Network News.
Gentlemen, describe to me EM1's mission. When, how long will it go? Where will it go? How do you see it playing out?
We can describe it to you, but there's probably a web link we can give you, Gina, that's even better, and then you can actually go look at it pictorially and see where it is. EM1 will go to a distant retrograde orbit around the moon. It's about a 21 to 25 day mission. I'm going from memory, so we'll get you the website and you can go look at it. But the purpose is we want to go into this distant retrograde orbit. It really stresses the exploration service module engine performance. It stresses our navigation capability. We want to really push the vehicle really hard from a test standpoint. And that's one difference between when we put crew on and when we don't have crew on. When we put crew on the vehicle, we would not do this same flight test sequence. We would stay close to the Earth for several orbits before we go around the moon. That's to check out systems. We would be poised. If something goes wrong, the crew could get back immediately. But since we don't have crew on this vehicle, we will push as hard as we can the Orion systems, the navigation systems, the propulsion systems. Then when we re-enter back in the Earth, we do a thing called skip cycle, where we actually enter into a portion of the atmosphere. We essentially come back out of the atmosphere a little bit, and then we re-enter again, and that allows us to target to land off the coast of California. We will stress that. We will pick very demanding regimes for all that to make sure that all the systems on Orion have been really stressed to the level, and then when we put crew on, we can back off of those requirements and operate, in more of kind of the middle of the design envelope down the road. But that basically describes, I think in the top level, what's on the M1 and how the flight is laid out. But we can give you some web references so you can actually go look at that for yourself.
All right, just a quick reminder, we've got a little more than 10 minutes left, so we'll keep going here. Operator, ready for the next question.
Our next question comes from Bill Harwood with CBS News.
Yeah, thanks. Either for Gerst or for Robert, one of the questions that I think a lot of reporters are always getting asked these days is, given the cost and complexity of the SLS system and all the problems that we've had getting to this point, and you have guys like, SpaceX saying, hey, I'm going to build a big rocket and send people to the moon in 2018. I realize I'm almost embarrassed to ask the question, but what do you say to people that raise that question? Why not SpaceX? Why not a cheaper rocket? Why are we going with SLS? Would like to have your explanation of that so I can tell folks what you think. Thanks.
I can start and Robert can kind of finish. We're really building this system. It is much more than one flight. We are using this unique capabilities of this rocket and the Orion capsule to essentially put a piece of infrastructure in space around the moon. We call it the Deep Space Gateway that can be used to do command robotic activities on the surface of the moon. It can be a staging point for later on Mars missions. So we're really taking, I would say, a methodical approach to really build an infrastructure that can be used by the private sector, and they can leverage off of this for their activities if they want to go do things, but it puts in place an overall system to move forward. So I would say we're taking a very measured but expedient as we can make it approach to try to put together in the key pieces of infrastructure that really make sense for us on the government side to put in place that can actually be used by a variety of commercial and international partners to advance their objectives in space.
Yeah, Bill, the only thing I'd add is that, I've been saying for a while, this is an and proposition. This is not an or. If you look at what we're trying to do, it's going to take both. It's going to take really all of us, frankly, to get this done. And I think when you look at how we complement each other, if you think about SpaceX and Boeing hopefully getting crews to the station here in 2018, we're going to utilize them to do that, and that's really what we're excited about them doing, and we're excited that we've been able to enable that industry and allow the commercial entities to come in to be part of this journey, right? Because that's what we're all on, is a journey. And so I don't look at it as an or, I look at it as an and that's the way we've been talking about it for a while.
Thanks.
Thank you, Bill. We are ready for the next question.
Next question comes from Nell Greenfield Boyce with National Public Radio.
When the first test flight flies without a crew in 2019, how much total will NASA have spent on the development of the SLS?
Maybe we can get that for you. I think the thing we've got to watch now is it's not, don't think of it as this mission. We actually have in flow today hardware and tanks for the second flight and the third flight. Actually, the teams are casting segments, are starting to prepare the solid rocket boosters for the second flight. So we're building this. Again, don't think of this as a single flight or a single activity. We're essentially building a multi-decadal infrastructure that allows us to move human presence into the solar system. So we can get you the specific number associated with just EM1, or we can get you the specific number we spent on the total program. We can give it to you a couple different ways. But I think we just need to be careful we don't focus on that number without realizing what we're really trying to put in place. And it's much more than a single system.
I guess I just want the numbers for the total program. I did not say I'm not under the impression that all you've been working towards is this one flight. I wanted to know how much the whole system will have cost NASA.
No, we'll look that up for you.
We can get that for you. We'll get you both Orion and SLS, and also the work at the Kennedy Space Center, because there's been a lot of activity done down at the Kennedy Space Center and other places as well. And it includes a whole variety of test stands at Marshall. It includes all this new manufacturing capability and Michoud. I mean, if you look extensively at the infrastructure that's in place, it's a lot of things. And so we'll show you what those numbers are. We'll give those to you.
Thank you.
Ready for the next question, please.
Next question comes from Tom Friesen with Aerospace America.
Yes, thank you very much. I'm curious about how this discussion on whether to include humans on EM1 began. Prior to the study that was announced in February, did this discussion begin with the Trump administration's NASA transition team that met at the end of 2016?
I think the way it worked is when the new team came on board, they asked us a lot of questions about a lot of things in the agency, and one of the things we talked about was the feasibility of putting crew on EM1, and so they asked us to go look at that, and we said we'd be glad to take that on. So I think it was typical of a lot of things that a new administration does when they come in, when they take on existing programs, just to see where they are and see if there's any things we can do differently. That's how it played out from my view.
Okay, we're going to take three more questions here before we have to wrap it up. We want to respect both Robert's and Bill's schedule here. Operator, we're ready for the next call.
Next question comes from Dan Vergano with BuzzFeed News.
Hi, guys. Thanks for doing this. I'm wondering if you're going to make the feasibility study for the lunar fly-around available or posted somewhere we could link to, let readers see it.
We don't really have it in, I would say, in a report format. It's a series of effectively view graph presentations and also detailed technical engineering. kind of documents and drawings, some of which are ITAR sensitive. So I don't think we'll make it public as a package or as a total report.
And we're trying to summarize that. We're going to summarize it in a form, and that's what we're going to try to provide for everybody. But we're trying to do that without dragging the teams in to write a report that, from that standpoint. So Bill and I have been working on a summary that we think would be applicable for everybody to see.
Great. Would love to see that. Thanks, guys.
Next question.
Next question comes from Marcia Dunn with Associated Press.
I can't help but think back to the 60s when 8 years go by between Alan Shepard's flight and landing on the moon for men. And lots of people ask me, what's different about today? Why is this dragging so long to especially get people up on the new rocket? What's different now from Apollo, for instance? And do you guys often think about that comparison as well? How, does it frustrate you?
I think that for us, it's a matter of within the resources we have, putting together a plan we think is the right plan for us to extend human presence, and we think we're on that plan. I mean, we get frustrated at the technical challenges and the things that pop up, but that's our engineering core. I think we also enjoy those. We enjoy tackling them, and this just isn't taking folks further than we ever have before. It just isn't necessarily the most easy proposition in the world. So the teams, but it's fun to watch the teams get excited about it and work through these challenges. I think, for us, it's as much an engineering challenge, putting together an entire program that's going to last, over decades, much better than from my perspective, much better than just a one-off kind of flight that we would do. And so I think that's the challenge for us. And I think we're looking for a sustainable program here, more than just one mission. I think that's where we are, Bill.
And I guess I would say, in the case of the lunar activity, it was a very focused, singular activity to accomplish one goal with a fairly high budget startup and ramp up to go do that single activity. It was focused to do one objective, and it was essentially to put men on the moon, where now we're building an infrastructure that supports more than one destination. I mean, this allows us to operate in the vicinity of the moon. If an international partner or commercial company wants to do surface activities on the moon, the infrastructure we're in place can support that. If we want to go to Mars, we can go to Mars. If we want to go to the moons of Mars, we can do that with this capability. So we're putting, I think, a much more robust foundation that supports multiple objectives in place. And that naturally takes a little bit longer than it does for a single kind of sprint to one destination and one specific objective. So we'll see how that works out, but that's what we're trying to do, is actually build an infrastructure that can be utilized by the private sector, utilized by the international partnership to essentially move human presence in the solar system. That's a grander vision in a way than just moving people to the moon for the first time, although that was a very special moment and a very special challenge for those teams moving forward. But we're building off of that legacy now to move in a more sustained manner.
Thank you, Marcia. Unfortunately, we're going to have to wrap it up with one more question. Operator, our final question, please.
Last question comes from Jason Ryan with Space Flight Insider.
Hey, thanks for doing this. My question, I guess, is for Bill. Bill, you mentioned some of the issues you had faced on SLS. Can you give us a brief overview of those issues, and with a focus on what the primary ones were that have kind of slowed you guys down a little bit, perhaps, and what is being done to address them? Thanks.
You're right. I would say, first of all, we ought to talk about just development in general, and it's not unique to SLS. One thing that's occurred, and it ties a little bit into what Marcia asked me about before, too, is our vendor and second-tier supplier base is a lot smaller today than it was before. So if you look at where, for example, large aluminum structure is being manufactured, we've probably filled up every large aluminum manufacturer and machining shop in the country with our activities. We've also asked for a lot of valves and components and wiring and avionics that there hasn't been a lot of development in that industry. So we're frankly having trouble going from a very small industrial base to now this big base we need. And I see that both on the European service module side, I see it on the Orion side, and I see it on the SLS side. So there's a shortage in manufacturing and production houses available to ramp up immediately from no orders to a bunch of orders to support our needs. So that's slowed us down some amount. I would say the other thing is some of the activities we assumed would be faster through the first, but the first time build of a device or component typically takes a little bit longer. And we're seeing that. I see that dramatically in Orion. Orion's first build for EFT1, there were lots of startup problems. There were lots of issues with timing of getting components and harnesses and things, and just assembly time took longer. The second flow for Orion, it made it down to the Cape within 1 or 2 days of our original schedule. So there's a big difference on the second time through for these devices. I saw the same thing on Space Station. When we built a truss from one side to the other side, the second time we built the truss, it was dramatically better. And so you're seeing some of that in SLS. This is first time build of, and you can think of it, a huge oxygen tank, a huge hydrogen tank, an engine section, and an an interstage that sits between the hydrogen oxygen tank. And that interstage is probably the loneliest element in the world. It carries all the load from the solid rocket boosters on the side, so it looks like just a can structure, but it is probably the most sophisticated load-bearing structure ever designed to carry all the load from the solid rocket boosters through that intertank region. So it's turned out to be able to manufacture that, and it has a lot of precision match drilling associated with that, and that's taken us a lot of time to go do that. So now what we're going to do is we think now we don't have to match drill those the second time through. We can actually have them pre-drilled. We can do that on an automated rig. So we'll figure out ways to reduce schedule the next time. So I would say that's just growth in manufacturing stuff. Then we've been surprised a little bit about the welding technology. I think that slowed us down a little bit more than we thought it would. But then I think I've also been surprised by some of the other things. The Ascent abort system is probably, it's a huge solid rocket motor, 700,000 pounds of thrust itself. It actually has the ability with a solid rocket system to provide attitude control. That was just recently tested in Maryland, and there's little pencils that have to cycle in and out to control the thrust of that device and maneuver it around. That's gone exceedingly well. So there's pieces where I'm surprised on the positive side, and then there's other things that you would think would be easy are not easy, and they take time. So hopefully that gives you some perception of what we're doing. And I could bring the engineers in and they could spend days with you explaining to you what's going on. But I think this is really important that you don't home in on the schedule. We may spend a little extra time refining the weld process, but that's really important now, because if I do that, then when I go forward and I start building stuff, they're building quality hardware every time. So sometimes you get tempted to go, well, we can just fix this now and not fix it right. The teams are spending the right time to put the right fixes in place. They're aware of schedule, but they're not so driven by schedule to meet a certain date that they're making shortcuts that will show up in later problems, show up in later production issues, or show up when the hardware actually goes and flies. They're taking the amount of time today to make sure we get quality systems out the other side that are available and for use for multiple decades in the future.
Okay, thanks everyone. Thanks Robert, Bill, for your time. Everyone else, you can listen to a replay of this teleconference in about an hour. You can dial toll free at 800-284-5340. The passcode is 2017-2017. Again, 800-284-5340 for a replay of this teleconference, and that replay will be available until June 12th. Otherwise, you can follow progress on SLS and Orion on our website, www.nasa.gov. If you have additional questions about EM1, please reach out to our Office of Communications at 202-358-1100, or you can email us at heo-pao as in HEO-PAO, at lists.nasa.gov. And obviously, we'll do our best to answer your questions. So thanks for joining us, and that will conclude today's call. Thank you.